with molecular compounds, we're not going to worry about making formulas or naming molecular compounds this semester, but what I do want to do is talk a little bit about using this important idea of showing how, for a molecular compound, how the atoms are arranged in something called a Lewis structure. So I'm switching gears to molecular compounds, and molecular compounds, remember, mean no metals allowed. And so for molecular compounds, we are just bonding nonmetals, which, if you remember the JAG in the upper right-hand corner of the periodic table, those are our nonmetals, and they are by far in minority as far as elements go. So I want to focus on molecular compounds and using Lewis structures, or introduce it anyway. So Lewis structures use what's called, of all the atoms that come together to make that molecule, in our cases, that molecule, of all the atoms that come together, basically each atom brings a certain number of valence electrons. And we talked about valence electrons is equal to the group number for the A elements, and that's all we're focusing on. So those electrons kind of collectively come together, and they are what we say distributed around that molecule, so that those pot of valence electrons, we'll be talking, I'm going to show you this in a Lewis structure, those valence electrons can either be bonding electrons or what we call lone pair electrons. This actually hopefully rings a bell. If you were to find carbon, you would find it in group or column 4A, nitrogen in 5A, 6A, oxygen, 7A, it's our halogen, and neon in that period 2 is 8A. It is actually our rare gas. So these are kind of giving you a sense for, these are Lewis dot structures of just the elements themselves. Where, for instance, if we pick on carbon here, that letter C actually is the nucleus, okay, and it is also the non-valence electrons. So if it's 4A, it has 4 valence electrons, so that makes these 4 dots, those are your valence electrons. That's kind of what this Lewis dot structure is saying. 5A elements have 5 valence electrons, and you can kind of see them around nitrogen. 6A elements have 6 valence electrons, you can see 6 dots around oxygen. 7A have 7 valence electrons. And 8A elements, the rare gases, actually have what we call a complete octet. They have 8 valence electrons around them. So when we talk here in a minute about a pot of valence electrons, we're going to actually have to revisit the periodic table and see what group they're in to know how many valence electrons an atom of that type of element would bring to the table. So Lewis structures then, this comes some of this I actually already said. Let's see, one of the things I didn't say a minute ago was, I don't know if you noticed, but there seemed to be kind of, if this is carbon, we kind of had a north, a south, an east, and kind of a west location. Those are just, I'll say bogus, but there really is no special significance like this says. To kind of show this concept here, I want to bring in this idea with carbon and hydrogen. So carbon is great at being able to kind of bond different ways. And so I want to show you what carbon does with hydrogen. So this would be what? C2H6. Okay? And this is a Lewis structure. So each one of those dashes actually represents, do I have it up here? Yes, I do. Okay. Each one of those dashes actually is 2 electrons. So 2 electrons there, okay, 2 electrons there, etc. So actually I could count electrons if I counted dashes. These are bonds. 1, 2, 3, 4, 5, 6, 7. So there are actually 7 bonds, and there's 2 electrons in each. So I have a pot of 4, or I am showing 14 electrons there, bottom line. Okay, now let me show you something else that carbon and hydrogen do. They also form this compound where I have carbon. Now I'm going to show 2 bonds, that's called a double bond, between the two carbons. And now I have hydrogens over here. I mention this now because we have 2 electrons there, but for this double bond right here, we actually have 4 electrons. So there are 4 electrons there in that double bond. If it was a triple bond, there would be what? 6 electrons. So that's kind of how that works.